All right, folks, here it is, lesson 12.6. Lesson 12.6 is about permutations and combinations. What we're looking for you guys to be able to do is to hopefully recognize that we are using a variation of the fundamental counting principle to make this stuff work out for us. So what we have, what we have here is some vocab. A permutation is a list of numbers in which the order matters. So we want to make sure that we understand that the order in which those things takes place is important. Kind of like when you go to your locker and you turn your dial to finally get into your locker. That is a permutation, unlike what it's called, which is called a locker combination. Now, a combination is something that's a little bit different, but a permutation is what your actual locker combination is, because the order in which you put them in matters. Those three numbers, you can't put them in just any random order. They have to be in a specific order for your locker to open. A factorial is when we have this little exclamation point. It means that we're going to have the product of all of the positive numbers that are less than or equal to that. So 5 factorial means 5 times 4 times 3 times 2 times 1. So you'll see here my permutation formula is we're going to find the number of permutations of n objects taken r at a time. So this is the formula that you're going to want to write down. It's n factorial divided by n minus r factorial. So n is the number of things that we're looking for, and then r would be the number of things that we actually have. So if you're looking for your locker combination, there's probably, I think, 50 numbers that you can choose from, and there's only 3 of them that you're going to have. So n would be 50, and r would be 3 in that case. All right, so let's check it out on this particular one. We have Shaquille. He has a 4-digit passcode to access his email account. The code is made up of even digits, 2, 4, 6, and 8. Each digit can only be used once, so how many different passcodes could Shaquille make? This is just us doing the 4 to the 4 factorial, because there's just those numbers. So we have 4 factorial. You just type it into your calculator. 4 times 3 times 2 times 1, and you get 24. And that tells us that he has 24 different permutations, or different ways that he could arrange those numbers to make his passcode work. So that's the answer for this first example. Example number 2. So we're going to use that formula that we had. It was for a permutation, we had n comma r. In this case, our n, the number of numbers we have, is 1, 2, 3, 4, 5, 6, 7. So we're going to have 7 factorial, because the formula is n factorial over n minus r factorial. So in our case, we have 7 factorial. We're using a 5-digit registration code. So we're going to have a 7 minus 5 factorial for the bottom. That makes 2 factorial, by the way. So what this looks like is we have a 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, we would have 2 times 1. So you'll see that my 2's cancel and my 1's cancel. So we're really just doing 7 times 6 times 5 times 4 times 3. So you take your trusty dusty calculator, 7 times 6 times 5 times 4 times 3, and you get the answer of the number of registration codes that are possible for this person is 2,520 codes that are possible. So that would be from us just doing this math right here that I just accidentally crossed out. All right, now our next thing is called a combination, and it's not what you think a combination is like your locker. This is the one where the order does not matter. A very similar type of a formula where n and r mean the same things, but there's just more math that we have to do. You can imagine that because the order does not matter, there should be more combinations than there are permutations, because the order doesn't matter. So you can put them in any which way you want, and it doesn't really matter. So here's our first example. A group of 4 seniors, 5 juniors, 7 sophomores volunteer. Mr. Fun Teacher needs 12. So 12 is my R, and all of the choices that we have would be then Rn. So I'm going to have my combination of my n comma r, my combination of my, see, 4 plus 5 plus 7, was that 16? And then comma r of 12. So into the formula, it will say a 16 factorial over a 16 minus 12 factorial times a 12 factorial. So when we type that stuff into your calculator, you're going to have a 16 times 15 times 14 times 13 times 12, yada, 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 yada. So you type it into your calculator with all the numbers after you write them down the long way, and we're going to get this taken care of here. So I have a 16 times 15, I've got, and I get this answer, holy cow, it's a lot of typing, of 1,820. And that's how this stuff works for us, folks. So you're just going to do this math, plug it on in. You're going to write it out the long way so you can see how things are going to cancel each other out. And then boom, we're golden. So this is the answer. We have one more problem I'll ask you guys to do on your own to see if you guys actually understand this permutation combination stuff. And then we'll go over this one when you guys return to class. All right, folks, this is the Burma Nation. I hope you have a wonderful day, a wonderful evening, a wonderful morning, whatever the heck it is, with whatever time you're watching this. Enjoy. Peace out.